Hello students, let's try to understand temperature dependence rate of reaction. That is how the temperature influence the rate of reaction, students. So let us try to understand, student. Rate of chemical reaction largely depends on temperature. The rate of reaction increases with rise in temperature. It has been observed that for a chemical reaction, rate constant increases 2 to 3 times with 10 degree rise in temperature. So Kt plus 10 degree upon Kt 2 to 3 degree. This ratio of rate constant is called temperature coefficient. Right, student? Now the next one is Arrhenius equation. So when you talk about Arrhenius equation, the quantitative relationship between rate constant of a reaction and temperature was proposed by Arrhenius equation. According to Arrhenius, reactions can take place only when reactant molecule collide with each other. What the point they are taking, student, according to Arrhenius, a reaction can take place only when reactant molecule collide with each other. This is the first point. Second point, collision of reactant molecule forms an unstable intermediate which exists for a short time and then break up to form the product molecule. So they are going to form the intermediate. Two reactant combined, they form intermediate and then decompose into the product, student. Now come to the third point. Reactant molecules required some amount of energy to form the activated complex, that is intermediate. This energy required to form intermediate is called activation energy. So activation energy is what energy possessed by the molecule to participate in a chemical reaction. Energy is released when activated complex decompose to form products. Profile of energy when reactant go into products is represented by the following diagram. So here the reactant molecule is more energy than the product molecule, student, because the here energy is released. That is why the product molecule is having the lesser energy, student. And this graph is what, that is potential energy, student, and at the top it is activated complex. Now this is the case of exothermic reaction, student. In case of exothermic reaction, the product is having lesser energy. But if the endothermic reaction is there, so product must be having more energy than the reactant. All the molecules in the reacting species do not have the same kinetic energy. The fraction of molecule which is given kinetic energy is calculated using Boltzmann and Maxwell statistics is what Ne by Nt is equal to E power minus Ea upon RT. The distribution of kinetic energy may be described by plotting the graph between fraction of molecule and the kinetic energy. So fraction of molecule is there and kinetic energy. The peak of the curve correspond to the most probable kinetic energy of the molecule, student. Now, when the temperature is raised, the maximum of the curve move to the higher energy value and the curve broaden out. Thus, proportion of the molecule with higher energy increases. So here is T is there and this is T plus 10. So proportion of molecule increases. The fraction of reactant molecule which collide with the energy greater than activation energy with increase in temperature. Seventh point, the rate constant of a reaction at any given temperature T is given by Arrhenius equation. K is equal to Ae minus Ea upon RT, where K is equal to rate constant of the reaction, A is Arrhenius factor or the frequency factor, its value is constant for a particular reaction. Activation energy Ea, R is the gas constant. So this is what the Arrhenius equation is, student, and theory of Arrhenius theory of temperature. Thank you.